Hello. In the last video, we relied heavily on our calculator in order to solve for x when we were converting between logarithmic and exponential form. But we can do a lot of this without our calculator by using some of the properties of logarithmic functions. Now, before we go over these properties that you may or may not have seen before, let's just talk about some exponential properties. If I have x to some power a times x to some power b, this would be equal to x to the a plus b. Right? This is something that we have dealt with and that we use on a regular basis. Now, since logarithmic functions are supposed to be the opposite of exponentials, we see this same rule with log. So if we're multiplying on the inside, so we have log of xy, then we can peel this apart with addition. This would be the same thing as log base b of x plus log base b of y. Well, all right. So if we know then how to rewrite x to the a divided by x to the b, we would know what this quotient rule is. And for our exponentials, when we're dividing by the same base, we subtract the exponents. And that's exactly what we'll do with log. If we are dividing on the inside, then we can separate this with subtraction. Now, the last one. If I have x to the a to some power, I would multiply my exponents. And that's kind of what's going on here. I'm going to multiply by my original piece. Now, another way to see this is if I said, okay, well, log base b of x squared, well, that's the same thing as x times x. And from my first rule, I could break that up as addition, and you see I get two copies of it. But if I had x cubed, I would just get 3 copies of addition. So that'd be 3 times. And so you can see how this power rule comes out of that. I'm going to erase this for a little bit of space. All right. So now the last one to keep in mind, this is a special case. If I have natural log of e to the x, well, natural logs are logs. So we could use this power rule to say this is the same as x times log, or natural log, of e. But natural log of e might be something special. So again, natural log is the same thing as log base e. And let's use a conversion. Let's just say we don't know what this is and convert this to exponential form. That says e to the y is equal to e. So I think we know what this is equal to. It's 1. So we have this nice property that natural log of e to the x is x. And even more so, we have this nice property that log base b of that same number is 1. Because again, b to the first is b. So then along this, one other property we have, something that we hinted at in the first video, b to some power is 1, always. And that's b to the 0 power. So using these properties and maybe some of these special properties, log base b of b is 1 or log base b of 1 is 0, we can simplify some expressions and solve for values. So let's do 2 examples. Here's our first example. What we're going to do is we're going to try to push this all together, or we can go ahead and push all of this to the other side and then convert. So let's try the second way. Let's get log x by itself. So that's 2 minus 3 log 2 minus or plus log 4. Now let's try to push this all together. So we're going to get log x is equal to 2. Well, remember, this 3 can go up top. So that's log 2 cubed. We could also combine these 2 pieces to be 2 minus log of 8 times 4, which should be log of 32. And now remember, this is some number. So if I converted this to this exponential form, and remembering what this base when I don't write it is, I could say this is 10 to the 2 minus log 32 is equal to x. Now that may look ugly, but this is some number. We could put this in our calculator. So this would just be our way to be able to solve for x. Now, we didn't have to do it that way. We could have tried to push all of this log together. So let's do that. Let's say we had this whole piece, and we'll bring our 3 up to get started. Now, addition means I'm multiplying these 2. So that's 8x. Subtraction means I could divide. That's log 8x over 4. Now we know what 8 over 4 is. That's 2x. And so that's saying 10 to the 2 equals 2x. And in this case, it was actually very clear what x was. So I wanted to do it these 2 ways to highlight that you can take very different paths in order to solve these, and some of the ways are going to be better than others. So in ALEKS, you're going to see a lot of times that they're going to give you something and they're going to make you push all of the logs together. In ALEKS, they're going to make you push all of these logs together. And this is normally the best way in order to solve the equation. Now, There are some where it's all pushed together, but because it is, we can't solve for the value we want. So in this case, we're going to use our properties of log to break this apart. So square root can be written as 3 divided by e to the x to the 1/2. Our 1/2 comes out. Now let's keep breaking this apart before we try to solve. Natural log of 3 over e to the x would be natural log 3 minus natural log e to the x. This x can come to the front with our product rule. Natural log 3 minus x, natural log e. But we've already seen that natural log e to the x is just x, because this natural log e is 1. And now this is a pretty normal equation in order for us to solve. We could multiply by 2 on both sides. We can add x over and get our answer. So sometimes, in order to solve for x, we're going to need to push all of our logs together, because then that way we can do something. We can solve, we can get into exponential form and solve. Other times, when it is already all together and we can't really do anything with it in that form, we'll need to peel it apart. And this will normally get our x by itself so that we can solve for it. And this is everything we need to know about the properties of logs to simplify expressions. And really our main goal in these sections was to get our 2 ways to solve equations.